Let's continue working on our blockchain now. I'll add a fourth option here with H for hack, and it'll be manipulate the chain. When we choose that, I actually want to manipulate a past transaction, and that is something we have to prevent in our blockchain, and we will prevent throughout this course. So let's first of all handle that case with another elif block, elif user choice equals H. Then I want to manipulate my blockchain, and I do want to manipulate it by simply accessing my blockchain, and I'll set my first element equal to 2 here. For that, I'll first of all wrap it in a nested if statement where I'll check the length of blockchain, and if that is greater than 1 or greater than equal to 1, so we have at least one element, I can manipulate that first element. And of course, we could outsource that into its own function too. It's not a core feature of our blockchain, though I just want to have that in there so that we can start manipulating it. Let's see this in action. If I save this and I now execute my blockchain file here, I see I got a typo here, so let's fix that and save again and restart. So now let's restart. If I now choose to manipulate right at the beginning, and I then output my blockchain, scroll up, you see nothing happens because we have no first element yet. So if I add a transaction value, 10, and I then output the blockchain, here's our first block. Let's add another transaction value, 3.8. Let's output the blockchain, first block and second block. And let's then press H to manipulate. And let's then output it again. And now you see in the second block, we're still referring to the original first block here, but the first block was actually overwritten. So that's the original first block. We had this dummy value at the beginning, and then we added our own transaction. But now the manipulated block is just 2. So it's totally different to our original first block. This is, of course, something we have to prevent, because even though we're just working with dummy numbers here, we're not handling real transactions with a sender and a receiver, our blockchain has to be safe. We have to ensure that you can't go there, sneak in, and manipulate past values. Our final blockchain will be secured against that, and we already can implement such a mechanism here. So let me quit and let's work on such a mechanism. Let's first understand what we exactly need to do to secure our blockchain. The goal is that whenever we edit some transaction, be that in the first block or in any other block, we actually notice that in the real blockchain. We'll notice it by the fact that the hash of that block changes, and the next block, which stores the original hash of the previous block, will notify that its stored hash and the now actual hash will not match anymore, and therefore it will render the entire chain invalid. Now, in our application here, we can kind of simulate this. Our chain looks something like this. We got our first block with the initial value in our first transaction. Then we got our second block and so on, which contains the previous block. The orange part here always is the previous block. And now what we want to do is we want to check that each block contains the value of the previous block. And if we change the value of the previous block, they will not equal. So we want to check if for a block, if its value contains the last block's value as a first element. So we want to check whether here these two are equal, or for the next block, if these two lists are equal, and so on. So this is the check we want to implement. We can do this with a loop. We can loop through all our blocks, and by doing that, we can ensure that we actually aren't able to manipulate our chain without ourselves recognizing it. Let's go back in our code, and let's add a new function, which I'll name verify chain. Now in this function, I'll add a loop which goes through the chain and checks whether it's valid. So whether the first element of a given block matches the entire last block's value. So how do we do that? We need a for loop here. We want to loop through all the blocks in our blockchain. That's for certain. Now, The goal is to compare the first value of a block with the entire last block due to the way our chain works. Remember, if you have a look at the output we had, before we manipulated it, the first element in our blockchain, remember this is the first element of this list, is equal to the entire last block because we keep on nesting these arrays. So first element of the second block is the entire last block. This is how our blockchain currently works. So we need to check if first element of this block is equal to the entire previous block. Therefore, in our blockchain here, we kind of want to check if block, and now its first element, is equal to what? Now we need to get the previous block, but in the for loop, we only got the block for the current iteration. We can't do block -1. That would just get the last value in that block, not in the blockchain. And we also don't want to get the last blockchain value. We want to get the previous one. So how can we fix that? We need to keep track at which element in our blockchain we're currently looking at. So I'll add a block index variable and set it to 0 initially. Then here in my for loop, I will check if block 0 is equal to block chain, so the entire chain, block index -1. So if the block index is 1, we're looking at the second element because the index starts at 0. And this will be this block, so the second block. So we'll check if the first element of the second block, the block is a list, remember? So if the first element of the second block is equal to our entire previous block, so the first block in our blockchain list in this case. Feel free to dump in some print statements if you're not sure what you're looking at exactly. So this is the check I want to perform. If they are equal, we know that the previous block is still the block we expected it to be. However, we of course need to check that for all blocks. So I will add a helper variable outside of the for loop, which is valid, and I'll set it to true initially. If we recognize that for this check at least, we still have a valid chain, I'll keep it set to true. Now, we also have an else case though. The else case is that this check here does not succeed. So we don't seem to have a valid chain. I'll therefore set is valid to false, and I will immediately break out of the loop because there's no reason to continue checking the blockchain if we already know that it is invalid. So I can quit the loop and break. And by the end, after my for loop, I will return is valid. I could also return here instead of break, but I want to return is valid in all circumstances. I want to return false in this case, but I also want to return true if we successfully loop through the entire chain. So this is now my blockchain looping logic here. Now we want to verify that chain whenever we, let's say, add a new transaction. Or maybe just whenever we're done with the user choice. So here I'll call verify chain after my if-else statement in the while loop. If I save it like this, not much will happen because verify chain will return true or false, but that alone doesn't do that much, right? We need to do something with that result in our loop. And what I want to do is I want to check if verify chain, if it's true, then I actually want to continue, but if it's not true, and here we can use the not keyword. So if this is not true, this is another application of not. We're just checking if this result here is false or true. And if it's not true, then we'll actually execute this code here and I will just break out of this while loop. So I want to quit. We could also, of course, print invalid loop. Let's do that maybe. So print invalid blockchain, I mean, not loop. So with that, we're executing verify chain. We're getting back true or false. Now, of course, we could do something if it's true, but I don't want to do anything there. I just want to continue. I'm only interested in the false case, and therefore the not keyword helps us filter for that case. If it's not true, we'll now execute this code, we'll leave the loop, and we'll print invalid blockchain. Now, our code has a problem though. Do you know which? The problem is that, of course, here we're also trying to check the previous element in the blockchain for the first iteration, so for the first block. There is no previous element in that case though. If we're at the beginning of the blockchain, if we're looking at the first element, there is no previous element. So what we actually want to do is we want to add another if check here and check if block index is equal to 0. If it is equal to 0, then I will just increment block index by 1. And here's a nice shortcut. You can use equals block index plus 1 or simply use plus equal. This will be the exact same. This is the same as saying block index equals block index plus 1. So we're incrementing block index by 1. There is no plus plus operator, by the way, as you might know it from other languages. So we're incrementing this by 1, and now I'll use continue because now I simply want to go on to my next iteration in that for loop, don't want to execute any other code. Of course, we should also increment block index regularly after this if else block here because we want to increment that by 1 once we're done with a block so that we always check the correct last block. And this if statement here should be elif now because it's an alternative to this first check. So now we got a if statement where we ensure that we're not running our logic for the very first block, that we do increment the block we're at, so the index with which we keep track of the current block, which we need to get the previous block by deducting 1 from it, and that we, well, correctly tell whether our chain is valid or not. So with that added, now if I execute this blockchain file here, if I add a transaction value like 10, you see that seems to work. If I output my chain, it's printing it here. If I add another value, maybe 5.5, seems to work. I'm still in the loop and we're outputting the value. Now, if I manipulate the chain though, you see we're getting invalid blockchain and we exit the loop and hence we're done with the script. Because once I manipulate my blockchain, this verify chain action we're always executing will fail, it will return false, and therefore it's not true, and therefore this code will execute. So this is now a way of verifying our blockchain. Now obviously we'll refine this throughout the course and use a more elaborate method for that, just as we'll have more complex transactions than, well, simple numbers. But this is actually a nice way of doing it right now.